Good day, everyone. Today, I will be presenting a detailed explanation of the comprehensive study on wireless network fundamentals. By the end of this presentation, you will have a clear understanding about wireless network fundamentals. Okay, then let's begin. I'm Tarusha Rajit Singh, a postgraduate student at the Sri Lanka Institute of Information Technology, currently pursuing a Master of Science in Information Technology. Okay, in this presentation, I will cover network models and protocols, data transmission and signal processing, error detection, correction, and control, antennas and wireless technologies, wireless LAN protocols and challenges, wireless LAN standards and its security. Okay, then let's move on to the first category, which is network models and protocols. Under this category, I will explain about the uh, ISO-OSI 7-layer architecture and TCP/IP model. Let's begin. Okay. The ISO-OSI 7-layer model is a conceptual framework developed by the International Organization for Standardization to standardize communication functions across different network systems. It consists of 7 layers and each responsible for a specific function in the communication process. Okay, let's break it down layer by layer. Okay, first one is application layer. This is a layer, seventh layer. This is the topmost layer and is close to the end user. It provides network services directly to applications like web browsers, email, clients, and file transfer programs. Uh, and protocol like HTTP for web browsing and FTP for the file transfer and SMTP for the email sending. Those are operates at this layer. The next layer is presentation layer. This layer is responsible for data formatting, encryption, and compression. It ensures that data sent from the application layer is in a format that the receiving system can understand. Examples include JPEG for images and MP3 for audio and SSL/TLS for encryption. Okay, the next layer is session layer. This layer manages sessions between applications. It establishes, maintains, and terminates connections between devices. Protocol like SIP, Session Initiation Protocol, and RTP, Real-Time Transport Protocol, operates here. And the next layer is transport layer. This layer ensures the reliable data transfer between devices. It handles segmentation, flow control, and error recovery. Protocol like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, operate at this layer. TCP provides a reliable connection-oriented communication, uh, while UDP offers faster and connection-less communication. Uh, okay, the next layer is a network layer. This layer is responsible for logical addressing and routing. It determines the best path for data to travel from the source to the destination. Protocol like IP and ARP and OSPF operates here. Next layer is data link layer. This layer handles physical addressing and ensures reliable data transfer over the physical medium. Uh, it is divided into two sublayers, MAC and LLC protocols like Ethernet 802.11 for Wi-Fi and VLAN operates at this layer. Okay, last layer is physical layer. This is the lowest layer and deals with the physical transmission of raw bits over a medium. It defines hardware specifications, signal types, and transmission rates. And examples are RJ45 connectors, DSL lines, and 802.11 wireless signals. Uh, those are the example of physical layer. The OSI model provides a clear framework for understanding how data flows through a network from the application down to the physical medium. Okay, then move on to the data encapsulation in the OSI model. Let's now explore data encapsulation in the OSI model. Uh, Encapsulation is the process of the adding headers to data as it moves down the OSI level. Uh, these ensure that the data can be properly transmitted, routed, and interrupted by the receiving devices. Uh, Here is how it works. You can see in application layer, uh, the process start at the application layer, where the user generates data such as an HTTP request or an email message. At this stage, the data is in its raw form. And then presentation layer, uh, as the data moves to the presentation layer, a presentation header is added. This header includes information about data formatting, encryption, and compression. And the examples is if the data is an image, the header might specify uh, that is uh, that is in JPEG format. Okay, so then move to the session layer. At the session layer, a session header is added. This header manages the session between the two devices, ensuring that the communication is properly established, maintained, and terminated. A protocol like SIP and RTP operates here. Okay, then move on to the transport layer. When the data reaches the transport layer, you can see a transport header, TCP header is added. This header includes information like source and destination port numbers and sequence numbers and error checking data. Those are the headers inside in TCP header. Those are the data inside in TCP header. If TCP is used, the header will also include acknowledgement information to ensure reliable communication. Okay, then move on to the network layer. At the network layer, an IP header is added. This header includes the source and destination IP addresses, as well as information about the packet's length and fragmentations. The IP header is the IP header for routing the data across different networks. Okay, then move to the data link layer. At the data link layer, a MAC header is added. This header includes the source and destination MAC addresses, which are used for physical addressing within a local network. The data link layer also adds a footer, which typically contains error checking informations like CRC. CRC means cyclic redundancy check. Okay. The last layer is physical layer. Finally, at the physical layer, the fully encapsulated frame is converted into the raw bit and transmitted over the physical medium such as an Ethernet cable or Wi-Fi signal. So at the receiving at the receiving end, the process is reversed, and each layer removes its corresponding headers until the original data is delivered to the application layer of the receiving device. This encapsulation and decapsulation process ensures the data is transmitted accurately and efficiently across networks. Okay, then move on to the next slide. Okay, this is about the TCP/IP protocol stack. Oh, now let's move on to the TCP/IP protocol stack, which is the practical implementation used in modern networking. Unlike the OSI model, the TCP/IP stack consists of 4 layers, each combining the function of multiple OSI layers. Here's the breakdown. uh, Application layer, transport layer, internet layer, and network interface layer. In application layer, it combines the functions of the OSI application, presentation, and session layers. It provides end user services and interfaces for network applications, protocols like HTTP, FTP, SMTP, and DNS operates here. This transport layer is a correspondent to the OSI transport layer and ensures the reliable data delivery. It uses protocols like TCP and UDP. TCP provides connection-oriented communication with error checking, while UDP offers faster connection-less communication. Okay, the next layer is internet layer. This layer corresponds to the OSI network layer and handle logical addressing and routing. The primary protocol here is IP, which assigns logical addresses to device and routes data packets between networks. Okay, the last layer is network interface layer. This layer combines the function of the OSI data link layer and physical layer. It handles physical addressing and the transmission of data over the physical medium. Protocol like Ethernet 802.11 and PPP. PPP means point-to-point protocol. Those protocols are operated in here. The TCP IP stack is the foundation of the internet and widely used in modern networking. Okay, then let's move on to the data encapsulation in TCP IP. Encapsulation is the process of adding headers uh, and sometimes footers to data as it moves down the stack. Here's how it works. First one is data. At the application layer, we start with raw data such as an HTTP request or an email message. Segment. When the data reach the transport layer, a header is added, creating a segment. This header includes information like source and destination port, uh, and sequence numbers and error checking data. If TCP is used, the segment will also include acknowledgement information also. Third one is packet. At the internet layer, an IP header is added, turning the segment into a packet. This header includes the source and destination IP addresses as well as information about the packet's length and fragmentations. The last one is frame. Uh, Finally, at the network interface layer, a header and footer are added, creating a frame. The header includes the source and destination MAC addresses, while the footer typically contains error checking information like a CRC. So this encapsulated frame is then transmitted over the physical medium such as an Ethernet cable or Wi-Fi signal. At the receiving end, the process is reversed with each layer removing its corresponding header until the original data is delivered to the application. Okay, then let's move on to the comparison of OSI and TCP IP models. Uh, OSI model uh, is a theoretical framework with the 7 layers. It provides a detailed and structured approach to understanding network communication, but it's not directly used in practice. But TCP/IP model is a practical implementation with 4 layers. It is a fun, foundation of the internet and is widely used in real world networking. So key similarities are both models divided uh, in a network communication into a layers. So they have layered architectures and they share similar functions at corresponding layers. Examples are transport layer in OSI and TCP/IP layer, OSI architecture and TCP/IP architecture in both. So key differences are the OSI model has 7 layers while the TCP/IP model has 4. The TCP/IP model combines the functions of the OSI application, presentation, and session layers into a single application layer. The TCP/IP model is more focused on practical implementation, while the OSI model is more theoretical. But both models are essential for understanding network communication, but the TCP/IP model is the one that powers the internet. Okay, now we'll move on to the next capture, which is data transmission and signal processing. Uh, so the first one is data and signal transmission. Let's now explore about data and signal transmission, a fundamental concept in wireless communication. Data is transmitted using signals, which can be either analog or digital. So, analog signals are continuous waves that vary in amplitude, frequency, or phase. Example includes AM, FM radio, and traditional telephone systems. And so analog signals are continuous waves that vary in amplitude, frequency, or phase. Example include AM, FM radio, and traditional telephone system. Signals are susceptible to noise and interference, which can degrade the quality of the transmission. So digital signals are the discrete signals that represent data in binary form. Uh, Digital signals are more robust against noise and interference, making them ideal for more modern communication systems like computer networks and digital televisions. So, modulation. Modulation is a process of converting a data into a signal for transmission. This essential for the transmitting information or a communication channel. Common modulation techniques include amplitude modulation, frequency modulation, and phase shift key. Factors affecting signals. Attenuation. This refers to the loss of signal strength as it travels through a medium. Attenuation can be caused by distance, obstacles, or the properties of the transmission medium. Distortion. This occurs when the signals change shapes due to imperfections in the transmission medium. Distraction can be lead to errors in the data interpretation. Uh, so interference, it's a external signal or noise can disrupt the original signals, reducing the quality of the transmission. Techniques like filtering and error correction are used to mitigate interference. So the next one is composite signal transmission. As shown the image, a composite signal is formed by combining multiple individual signals into a uh, uh, single signal for transmission. At the sender, multiple signals are combined into a composite signal. At the receiver, the composite signal is decomposed back into the original components, and however, due to factors like noise, interference, or propagation delays, the received components may be out of the phase with the original signals. This can lead to errors or distortion in the received data. So understanding these concepts is crucial for designing efficient and reliable wireless communication system. By selecting the appropriate signal type, modulation techniques, and addressing factors like attenuation, distraction, and interference, we can optimize the data transmission for various applications. Okay, let's move on to the noise and delay. So, uh, there's a two crucial factors that impact the performance of the wireless communication system. First one is noise, second one is delay. So noise refers to unwanted signals that interference with the original signals, reducing the quality of the transmission. There are several type of noises: thermal noise, intermodulation noise, and crosstalk. So thermal noise caused by the random movements of the electrons in a conductor. It's a present in all electronic devices and increases with a temperature. Intermodulation noise occurs when multiple signals interact and produce a new frequencies, leading to interference. Crosstalk is interference caused by adjacent communication channels, often seen in the telephone lines or network cables. As shown in the first image, uh, noise can distort the original signal, making it harder for the receiver to interrupt the data accurately. Okay, Then move on to the delay. Delay refers to the time it takes for a signals to travel from a sender to the receiver. There's a several type of delays: propagation delay, transmission delay, and processing delay. So propagation delay uh, takes for a signal to travel through the mediums such as air or cable. A transmission delay required to push all the bits of uh, of a packet onto the link. Uh, Processing delay taken time by network devices such as routers or switches to process the packet headers. So, as shown in the second image, delay can be caused echo effects, where the signal is reflected back, creating multiple copies of the original signal. This is particularly problematic in voice communication, where echoes can make conversational difficult to understand. So, impact of noise and delays. Actually, noise and delay can significantly degrade the performance or performance of wireless network. Noise reduce the signal quality, leading to errors and data loss, while delay causes latency, making real-time communication less efficient. To mitigate these issues, techniques like error corrections, signal filtering, and synchronization are used. So understanding noise and delay is essential for designing a robust and efficient wireless communication system. Okay, then move on to the transmission media. Uh, the physical pathways through which data is transmitted in a network. There are three primary types of transmission media: copper cables, fiber optic cables, and free space wireless. Copper cables, such as twisted pair and coaxial cables, are widely used due to their affordability and ease of installation. Uh, Twisted pair cables consist of pairs of insulated copper wires twisted together to reduce electromagnetic interface, and they are commonly used in Ethernet network. Coaxial cables have a central copper conductor surrounded by insulation, copper or aluminum mesh, and an outer protective cover. Uh, they are used in cable, television, and older Ethernet network. However, copper cables are susceptible uh, to electromagnetic interface and have limited bandwidth, which can restrict their use in high-speed networks. Okay, fiber optic cables use light to transmit data, offering a significantly high bandwidth and a longer transmission distance compared to the copper cables. So the structure of this is actually a fiber optic cable consists of a glass fiber core surrounded by uh, cladding and protective jacket. The core carrier uh, that light signals, while the cladding reflects the light back into the core to minimize this signal loss. So fiber optic cables are immune to electromagnetic interface, making them ideal for high-speed network. However, they are more expensive and difficult to install than copper cables. Free space. Free space transmission or wireless communication uses radio signals to transmit data through the air. The type of transmission is highly flexible and enable mobility, making it ideal for applications like Wi-Fi, cellular network, and satellite communication. But however, wireless communication is susceptible to interface and signal attenuations, which can degrade the quality of the transmission. Understanding the advances, understanding the advantages of uh, uh, understanding the advantages and disadvantages of these transmission media is crucial for designing efficient and reliable networks. By selecting the appropriate medium for a given application, we can optimize network performance and meet the specific needs of users. Okay, now move on to the standards bodies. So these organizations play a crucial role in developing and standardizing technologies to ensure that devices and systems can work together seamlessly. So, role of standards bodies. Uh, Actually, standards bodies establish protocols and guidelines that ensure interoperability and compatibility between different devices and systems. Without these standards, devices from the different manufacturers might not be able to communicate effectively. Uh, Key standards of bodies, uh, IEEE, one of the most prominent standards bodies. IEEE is responsible for developing widely used standards like IEEE 802.11 and IEEE 802.15. Uh, I, 802.11 for Wi-Fi, 802.15 for Bluetooth. These standards define how wireless devices communicate the connect. ITU, International Telecommunication Union. The ITU regulates global telecommunications and sets international standards for technologies like radio, television, and satellite communication. IETF, Internet Engineering Task Force. The IETF developing and promotes internet standards, ensuring that the internet operates smoothly and consistently across the globe. So the next one is 3GPP. Uh, 3GPP means Third Generation Partnership Project. This body is responsible for standardizing cellular communication technologies, including 4G, LTE, and 5G. These standards define how mobile networks operate and evolve. Importance of standards bodies. Standard bodies ensure that wireless communication technologies evolve in a consistent and inter, interoperable manner. Cut. Importance of standards bodies. Standard bodies ensure that wireless communication technologies evolve in a consistent and interoperable manner. This enables seamless uh, connectivity across an network, allowing users to enjoy reliable and efficient communication. For example, thanks to standards like IEEE 802.11, you can connect to Wi-Fi network using devices from different manufacturers without any issues. Similarly, 3GPP standards ensures that your smartphone can connect to 4G or 5G network worldwide. In conclusion, standards bodies are essential for the development and evolution of wireless communication technologies. They provide a foundation for interoperability, enabling and the connected world we live in today. Okay, now let's explore signals, filters, and bandwidth. So, which are critical components of wireless communication system. Signals. In wireless networks, signals are electromagnetic waves that carry information from one point to another. These signals can be either analog or digital. The characteristics of signals, such as its frequency, amplitude, and phase, determine how it proceeds and transmitted. For example, in Wi-Fi, signals are transmitted at specific frequencies. Like examples are 2.5 gigahertz or 5 gigahertz to carry data between devices. Filters. Filters play a crucial role in wireless communication by allowing specific frequency components of a signal to pass while attenuating others. This is essential for minimizing interference and ensuring that only the desired signals are processed. Filters can be classified into four main types: low pass filters, high pass filters, band pass filters, and band stop filters. As shown in the image, a filter can remove noise from a signal, leaving only the clean, desired signal for further processing. Okay, bandwidth. Bandwidth refers to the range of frequencies that a signal occupies. Uh, in wireless communication, bandwidth is a crucial resource that determines the data rate and capacity. Uh, wider bandwidth allows for higher data rates, enabling faster communication. But however, it also requires more power and can be more susceptible to interference. So, in summary, understanding signals, filters, and bandwidth is essential for designing efficient and reliable wireless communication systems. By carefully managing these components, we can ensure high quality data transmission and optimal network performance. Okay, now we'll discuss about the pulse code modulation. Pulse code modulation widely used digital modulation techniques for converting analog signal into a digital form. PCM is essential in wireless communication system due to its ability to provide high quality signal transmission and robustness against noise. So, what is PCM? Pulse code modulation is a digital modulation technique that converts analog signals such as voice or music uh, into a digital data. This process involves three main steps: sampling, quantization, and encoding. Okay, then let's move on to the steps of PCM. First one is sampling. Sampling, where the amplitude of the analog signals is measured at the regular intervals. According to the Nyquist theorem, the sampling rate must be at least twice the highest frequency component of the signal to accurately reconstruct the original signal. Quantization, uh, here the sampled amplitude values are mapped to the finite set of levels, and the number of quantization levels determines the resolution of the digital signal. More levels provide high resolution but require more bits to represent each sample. Encoding. Uh, the final step is actually encoding, where the quantized samples are converted into a binary code. The binary code represents the amplitude of each sample, and the resulting digital signals can be transmitted over a wireless channel. Okay, applications of PCM are digital audio and telephony, uh, wireless communications. Those are the application using PCM. So advantages of PCM are actually PCM provides high quality signal transmission by accurately converting analog signals into a digital form. It's robust against noise, making it ideal for wireless communication system where the interface is common. PCM is widely adopted in wireless applications due to its reliability and efficiency. So in conclusion, pulse code modulation is a fundamental techniques in digital communication, enabling high quality and noise resistant transmission of analog signals in digital form. Its applications in digital audio, telephony, and wireless communication highlight its importance in modern communication systems. Now let's explore modulation techniques in wireless communication. Modulation is the process of varying the properties of a carrier signal, such as its amplitude, frequency, or phase. To encode information, this is essential for transmitting data over a long distance and enabling multiple signals to share the same communication channels. So, analog modulations uh, can be divided by two parts, amplitude modulation and frequency modulation. Uh, in AM, the amplitude of the carrier signal is varied in proportion to amplitude of the modulation signal. AM is signal. AM is simple to implement, but it's susceptible to noise and interference. It is commonly used in AM radio broadcasting. FM uh, FM means frequency modulation. Uh, FM, the frequency of the carrier signal is varied in proportion to the amplitude of the modulating signals. FM is more resistant to noise and provides better signal quality, making it suitable for applications like FM radio broadcasting. The next one is digital modulation. Uh, They can be divided by three parts, which are amplitude shift keying, frequency shift keying, and phase shift keying. ASK, amplitude shift keying, varies the amplitude of the carrier signals to represent binary data. Different amplitude levels correspond to different binary values. ASK is simple but less robust against noise. FSK varies the frequency of the carrier signal to represent binary data. Different frequencies correspond to different binary values. FSK is more resistant uh, to noise than ASK. PSK. PSK varies the phase of the carrier signals to represent binary data. Different phase shift correspond to different binary values. PSK is widely used in modern communication systems due to its efficient and robustness. Okay, and now let's move on to the comparison of modulation techniques. So, as shown the image, AM and FM are used in analog communication, while ASK, FSK, and PSK are used in digital communication. Each modulation technique has its advantage and disadvantage. For example, AM is simple but susceptible to noise. while FM is more robust but uh, requires more bandwidth. In digital communication, PSK is often preferred for its efficiency and resistance to noise. So, in conclusion, modulation techniques are essential for wireless communication, enabling the transmission of information over long distance and sharing of communication channels. By selecting the appropriate modulation techniques, we can optimize the performance of wireless communication system for various applications. Okay, now we'll move on to the multiplexing in wireless communication. A technique that allows multiple signals to share the same communication channel, increasing the efficiency and capacity of the network. So, what is multiplexing? Multiplexing is a process of combining multiple signals into a single signal for transmission over a shared medium. This allows multiple users to share the same communication channel, making the network more efficient and increasing its capacity. Type of multiplexing. First one is frequency division multiplexing. FDM is divides the available bandwidth into multiple frequency bands, with each band assigned to a different signal. For example, in FM radio, different stations are assigned different frequency bands to avoid interference. Uh, Time division multiplexing, TDM. TDM divides the available time into a multiple time slots, which each slot assigned to a different signal. This commonly used in digital communication system, where each user gets a specific time slot to transmit data. Code division multiplexing, CDM. CDM assigns a unique code to each signal, allowing multiple signals to share the same frequency band simultaneously. This technique is used in a cellular network where multiple users can communicate on the same frequency without interfering with each other. So next one is orthogonal frequency division multiplexing. OFDM is widely used multiplexing technique in modern wireless communication systems. It divides the available bandwidth into multiple orthogonal subcarriers, with each subcarriers modulate by a low rate data stream. So, importance of multiplexing. Multiplexing is essential for optimizing the use of limited bandwidth in wireless communication. By allowing multiple signals to share the same channel, multiplexing increases the network's capacity and efficiency. Techniques like FDM, TDM, CDM, and OFDM enable modern wireless systems to support a large number of users and high data rates, making them ideal for applications like mobile communication, Wi-Fi, and streaming service. So in conclusion, multiplexing is a key technique in wireless communication that enables efficient use of bandwidth and support high capacity networks. By understanding and implementing multiplexing techniques, we can design wireless systems that meet the growing demand of the modern communication. Okay, let's move on to the logarithms and the decibel values, uh, which are essential concept is in wireless communication, practically for analyzing signals, strength, and noise of system performance. So logarithms is a mathematical function that measures the power of power to which a base number must be raised to produce a given number. In wireless communication, logarithms are used to simplify the representation of large range of the values such as signal, power, levels, and noise. For an example, instead of working with very large or very small numbers, we can use algorithms to express these values in a more manageable form. Decibel, dB. Decibel is a logarithm unit used in expressed to the ratio of two power levels. It's commonly used in wireless communication to describe signal strength, attenuation, and noise levels. So, for an example, signal to noise ratio, I can say SNR, is often expressed in a decibel. A higher SNR indicates a strong signal relative to the noise, which is crucial for reliable communication. So, application of dB in wireless communication, uh, signals to noise ratio, path loss, antenna gain. Yeah, those are the application of decibel in wireless communication. So in conclusion, logarithms and decibel values are fundamental tools in wireless communication, enabling engineers to analyze and optimize the system performance efficiently. By understanding those concepts, we can design more efficient and reliable wireless networks. So digital signals and bandwidth basics. So those are the fundamental concepts in wireless communication. Digital signals are discrete time signals that represent information in binary forms, unlike analog signals, which are continuously in both time and amplitude. Digital signals are uh, sampled at regular intervals and quantized to finite set of levels. Bandwidth. Bandwidth is a crucial parameter in digital communication as it determines the maximum data rate that can be transmitted over a channel. Bandwidth is related to a bit rate, which is the number of bits transmitted per second. Importance of bandwidth and modulation. Selecting the appropriate bandwidth and modulation scheme is essential for optimizing the performance of wireless communication system. For an example, in 5G networks, advanced modulation techniques like QAM are used to achieve high data rates, while careful bandwidth management ensures efficient use of the available spectrums. So the conclusion is digital signals and bandwidth are key concepts in wireless communication. By understanding how digital signals work and how bandwidth affect for data transmission, we can design more efficient and reliable communication systems. Okay, now let's move on to the calculation uh, to understand how Naige's theorem is applied to the calculate the maximum bit rate for a digital signal. So, given bandwidth, B is equal to 10 megahertz, and number of signal levels refers as L uh, is 16. So the Naige's theorem state that maximum bit rate of a noiseless channel is given by the formula is maximum bit rate is equal to 2b log L. So B represents bandwidth, L represents number of signal levels. So finally, you can get maximum bit rate as 80 Mbps. 80 megabits per second. So this example demonstrates how the Nyquist theorem is used to calculate maximum bit rate of a digital signal. Okay, let's now discuss signal transmission and bandwidth principles, which are fundamental to wireless communication. Signal transmission involves the propagation of electromagnetic wave through the air or other media. The quality of signal transmission is influenced by factors such as frequency, distance, and environment conditions. So, higher frequency signals, such as uh, those used in microwave and millimeter wave communication, often higher data rates. But however, they are more susceptible to attenuation and interference. Bandwidth is a crucial parameter in wireless communication as it determines the amount of information that can be transmitted over a channel. The Shannon-Hartley theorem provides the theoretical limits on the maximum data rates of a communication channel. Uh, Here is the formula of the Shannon-Hartley theorem. It, C represents as channel capacity, B represents as bandwidth, and SNR is represent as signal to noise ratio. So, importance of bandwidth is often a secure resources in wireless communication. Efficient use bandwidth is essential for maximizing the capacity of the network. So, in summary, understanding signal transmission and bandwidth principle is crucial for designing efficient and reliable wireless communication system. So now let's work through an example to understand how the Shannon-Hartley theorem is applied to calculate the maximum channel capacity. So given bandwidth is, let's assume it's 5 megahertz and SNR is 30 decibel. So according to these steps, finally, we can get uh, uh, answer as 49.85 Mbps. So with a bandwidth of 5 megahertz and SNR of 30 decibel. This example demonstrates how the Shannon-Hartley theorem is used to calculate the maximum data rate of communication channel, which is essential for designing efficient wireless network. So next, move on to the next chapter, which is data transmission and network processing. So uh, now let's discuss error detection, a crucial aspect of wireless communication system. In wireless network, data is transmitted over potentially noisy channels where errors can occur due to factors like interference, signal attenuations, and multipath propagations. To ensure data integrity, several error detections techniques are employed. Uh, First one is importance of error detections. Error detections ensures that the data received is the same as the data sent, even in the presence of noise and interference. Without error detection, corrupted data could lead to incorrect result or system failures. Error detection techniques. First one is parity check. This is one of the simplest form of error detection, and adding a bit called the parity bit is added to a data you need to make the total number of one either even or odd. If the received data does not match the accepted parity, an error is detected. However, parity checks are limited in their ability to detect multiple errors. Uh, Cyclic redundancy check (CRC). CRC is more robust error detection method. It used polynomial divisions to generate a checksum which is appended to the data. Checksums. Checksums involves summing the bits in a data unit and sending the results along with the data. The receiver performs the same calculation and compares the results with the received checksum. CRC process. As shown in the image, the sender appends a CRC checksum to the data before transmission. The checksum is generated using polynomial division. At the receiver, the same polynomial division is performed on the receiver data. If the remainder is zero, the data is considered error-free and is uh, and it is accepted according to the uh, considered uh, receiver's response. If the remainder is non-zero, an error is detected and the data is rejected. So in conclusion, detection techniques like parity check, CRC, and checksums are essential for ensuring data integrity in wireless communication systems. Okay, next let's discuss error control in the data link layer. Uh, it is essential for ensuring the integrity of data transmitted over a network. Error control techniques help detect and correct errors that occurs during transmission, ensuring reliable communication. The purpose of the error control are the primary goal of the error control is ensure that data transmitted accurately and efficiently. Uh, so error detection means identifies errors in the received data. Error correction means corrects errors without requiring retransmission. So retransmission means resend the data that has been lost or corrupted during the transmission. ARQ, automatic repeat request. One common error control technique is the automatic repeat request protocol. In ARQ, the receiver sends an acknowledgement to the sender when data is received correctly. If the sender does not receive an acknowledgement within a specified timeout period, it's retransmit the data. This ensures reliable data transmission even in noisy environments. Error correcting codes. Another error control technique is the use of error correcting codes, such as Hamming codes and read Solomon codes. These codes are redundancy to the data, allowing the receiver to detect and correct errors. Importance of error control. Error control is essential for maintaining the integrity of the data in wireless networks. By detecting and correcting errors, these techniques ensure that data transmitted accurately and efficiently even in challenging environments. Okay, here we'll move on this image. The stop and wait ARQ is a fundamental error control protocol used in data communication. It ensures that each frame sent by the sender is correctly received before sending the next one. Let's go through the process of step by step. First, sender transmit the frame 0 to the receiver. The receiver successfully receives it and sends an acknowledgement, which is ACK0. The sender then sends frame 1 and the receiver acknowledges it with ACK1. However, when frame 2 is sent, it gets lost in translation. Since the sender does not receive an acknowledgement, it assumes that the frame did not arrive. Meanwhile, the sender proceeds with the frame 3, but the receiver uh, detects that frame 2 is missing in sequence. The receiver then sends a negative acknowledgement to request retransmission. Upon receiving the negative acknowledgement, the sender resends frame 2 and ensuring that all frames are received in correct order. This protocol is simple and reliable, but it can be slow because the sender must wait for an acknowledgement before sending the next frame. In high-speed network, more efficient protocols like go back NARQ or selective repeat ARQ are used. Okay, let's move on to the new chapter, which is antennas and wireless technology. Uh, so, what is an antenna? An antenna is a transducer that converts electrical signals into electromagnetic waves and vice versa. It is essential for transmitting and receiving radio frequency signals in wireless communication systems. So, the performance of an antenna is characterized by several key parameters, which are gain, directivity, radiation patterns, uh, impedance, and bandwidth. So antennas are classified into various types and each suited for specific applications. Like dipole antennas, these are commonly used in radio and television broadcasting. And parabolic reflectors, these are used in satellite communication due to their high directivity and gain. And understanding antenna theory is a crucial for designing efficient wireless communication system. By selecting the right antenna and optimizing its parameters, we can ensure reliable signal transmission and reception even in challenging environments. So, in conclusion, antenna theory is a fundamental aspect of wireless communication, enabling the designing of antennas that meet the specific needs of various applications from broadcasting to satellite communications. So now let's discuss about how cell tower work, which are the backbone of the cellular network. Cell towers are also known as base stations, facilitate wireless communication between mobile devices and the core network. So, what's a cell tower? A cell tower is a structure that houses the equipment needed to transmit and receive wireless signals. It consists of antennas, transceivers, and baseband equipment. Likewise, this. The coverage areas of cell towers is divided into sectors, each served by directional antennas. This helps optimize signal strength and reduce interface. So, how cell tower works? When a mobile device initiates a call or data session, it sends a signal to the nearest cell tower. Then the tower transceivers receive the signal, process it, and forward it to baseband unit. The baseband unit converts that signal into the uh, format suitable into a format suitable for the transmission over the core network, which routes the signal to its destination. Uh, Key concept in cellular networks. So frequency reuse. To increase network capacity, the same frequency band is used in the non-adjacent cells. This allows multiple users to share the same frequency without causing interference. Second one is handover. As the mobile device moves from one cell to another, the network ensures a seamless communication by transferring the connection from one cell tower to another. This process is called handover. So let's discuss about modern cell towers. So modern cell towers support multiple generations of wireless technology, including 4G LTD, LTE, and 5G. They employ advanced techniques like beamforming and MIMO. MIMO means multiple input, multiple output. From that, it's enhanced capacity and the coverage. Beamforming focuses the signal in specific directions, improving the signal strength and reducing interface. MIMO uses multiple antennas to transmit and receive data simultaneously, increasing data rates and reliability. Uh, so, cell towers are essential for providing reliable wireless communication, and they enable us to make calls, send message, and access the internet from our mobile device. So in conclusion, cell towers are the backbone of the cellular network, enabling the seamless communication between mobile device and the core network. Okay, so next let's discuss antenna beamforming. So what is beamforming? Beamforming is a technique used to direct transmission or reception of signal in a specific direction. It's achieved by combining the signal from multiple antennas in a fast array to create constructive and destructive interface patterns. Uh, so constructive interface strengthens the signal in the desired direction, while a destructive interface cancels out signals in unwanted directions. So benefit of beamforming, actually it's improved signal quality, and also it's increased the data rate, and it extends the coverage by directing a single tower users. Beamforming can extend the coverage area of cell tower, especially in environments with the obstacles or high interference. So beamforming can be implemented using analog and digital technique. Uh, so adjust the phase and amplitude of the signal at the radio frequency stage. This is simpler but less flexible. Digital beamforming process signals in the baseband, allowing for more precise control and flexible. This is commonly used in modern systems like 5G. Beamforming is a key technology in massive MIMO, which is used in 5G networks. So beamforming is essential for improving the performance of wireless networks, especially in crowded or challenging environments. It enables uh, higher data rates, better coverage, and more reliable connection. Okay, now let's discuss MIMO antenna technology, which is so what is MIMO? So MIMO technology used multiple antennas at both the transmitter and the receiver to improve communication performance. It exploits multi-path propagations where signals reflect off a surface and arrives the receiver via multiple paths. So systems are characterized by three main features, which are spatial multiplexing, uh, diversity gain, and array gain. Partial multiplexing allows multiple data streams to be transmitted simultaneously over the same frequency band, significantly increase the capacity of the communication channel. So MIMO diversity gains improves reliability by transmitting redundant copies of the data over different paths. If one path is blocked or degraded, the receiver can still recover the data from another path, reducing the likelihood of errors. So from the array gain, it's coherently combining a signal from multiple antennas, and MIMO systems can enhance the overall signal strength, improving the quality of the received signal. So MIMO is a key technology in modern wireless standards, include Wi-Fi and 4G, 5G cellular network. Uh, yeah. So massive MIMO is a key technology in 5G network. It uses a large number of antennas at the base station to serve multiple users simultaneously. So MIMO technology is essential for meeting the growing demand from high-speed wireless communication. By increasing data throughput, improving reliability, and enhancing signal strength, MIMO enables modern wireless systems to deliver faster and more reliable connectivity. So next, let's discuss smart antenna technology. What is smart antenna tech? What is smart antennas? So smart antennas combines the antenna array with signal processing algorithms to adaptively optimize radiation patterns. This adaptively makes smart antennas highly effective in improving network performance, especially in environments with high interference or varying signal conditions. So smart antennas are classified in two main types, which are switched beam systems and adaptive error systems. So benefits of smart array antennas are reduces the interference, and it increases network capacity, and it extends the coverage. So, smart antennas are widely used in various applications, including cellular networks, satellite communication, and radar systems. So, in conclusion, smart antenna technology is a powerful tool for optimizing wireless communication systems. Its ability to dynamically adjust beam patterns make it ideal for application in cellular network, like satellite communication and radar systems. So now let's discuss about half duplex and full duplex. In half duplex communication, it occurs in both directions but not simultaneously. This means that devices can either transmit or receive data at any given time, but not both at the same time. In full duplex communication, it occurs simultaneously in both directions. This is achieved by using separate frequency band for a transmission and reception. So FDD is widely used in cellular networks such as 4G Lite and 5G. So comparison of HDD and FDD is uh, uh, HDD advantages are simpler to implement and requires less bandwidth. But uh, FDD allows simultaneously two-way communication, uh, and it's ideal for real-time application like voice call and video streaming. Uh, HDD have less efficient for real-time communication as devices must take turns transmitting and receiving, and also FDD is also more complex to implement. That's the disadvantages of both technologies. Uh, uh, FDD is more complex to implement and it requires to sufficient frequency to separation to avoid interference. So HDD commonly used in walkie-talkies and older wireless networks and applications where simultaneous communication is not necessary. And also FDD used in modern cellular networks. Okay, now let's discuss multiple access technologies. So, what's the purpose of the multiple access technology? Access technology allows multiple users to share the same communication medium, such as a frequency band or time slots, without causing interference. This is crucial for increasing the capacity and efficiency of wireless network. Uh, There are several common multiple access technologies, uh, which are FDMA, TDMA, CDMA, and OFDMA. FDMA means frequency division multiple access. So FDMA divides the available frequency band into a multiple channels, with each channel assigned to different user. This is similar to how radio stations operate on different frequencies. TDMA means time division multiple access. It divides time into a slot, allowing multiple users to share the same frequency band by taking turns. CDMA. CDMA means code division multiple access. CDMA uses unique codes to differentiate users, allowing multiple users to transmit simultaneously on the same frequency. Each user's signals is encoded with a unique code which the receive user to separate the signal. Normally, CDMA is used in 3G technologies, 3G networks. So OFDMA, orthogonal frequency division multiple access. OFDMA divides in the frequency band into multiple orthogonal subcarriers with each subcarrier assigned to different user. This technique is highly efficient and resistant to multipath fading, making it ideal for 4G and 5G networks. So FDMA is used in 1G cellular network, TDMA is used in 2G network, example is GSM, CDMA used in 3G networks, OFDMA used in 4G and 5G networks. Okay, now we'll move on to next new capture, which is wireless LAN protocols and challenges. Uh, so now let's discuss about CSMA-CD and CSMA-CA, two protocols used to manage access to the shared communication media in wired and wireless network. CSMA-CD is used in wired Ethernet networks. It allows devices to detect collisions and retransmit data after a random backoff period. Uh, Here's how it works. Before transmitting, a device listening to the network to check if the medium is busy or not. If the medium is idle, the device starts transmitting. If two devices transmit simultaneously, a collision occurs. The devices detect the collision and stop transmitting. After a random backup period, the devices retransmit their data. CSMA CD is effective in wired network where collisions can be detected quickly. CSMA-CA is used in wireless Wi-Fi network. It avoids collisions by using request to send and clear to send handshake mechanism. Here's how it works. Before transmitting a device, send an RTC frame to the access point uh, to request permission to transmit. If the medium is available, uh, the, a, the access point responds with a CTS frame granting permissions. The device then transmits its data and this handshake ensures that other devices defer their transmission, preventing collisions. GSMA-CA is essential in wireless network where collision detection is challenging due to the hidden terminal problem. Uh, Comparison of CSMA and CCD uh, and CSMA and CA. CSMA-CD detects collision after they occur, and it's used in wired network. But CSMA-CA prevents collision before they occur. So it's used in wireless network. Those are the main differences among CSMA-CD and CSMA-CA. So CSMA-CD used in Ethernet networks where collision detections is feasible due to the wired medium. Uh, but CSMA-CA used in Wi-Fi networks. So those protocols are essential for managing access to shared communication media, ensuring efficient and reliable data transmission in both wired and wireless networks. Okay, now let's discuss about the collision detection in older networks. In older networks, such as early Ethernet systems, collisions occurred when two or more devices transmitted data simultaneously. This led to data corruption and reduced network efficiency. To address this problem, uh, uh, carrier sense multiple access with collision detection, that means CSMA-CD, was introduced. CSMA-CD is a protocol that allows devices to detect collisions and manage retransmission. So here's how it works. Before transmitting, a device listens to the network to the check if the medium is busy, and then if the medium is idle, uh, just like the previous as well, previous discussion, the device start transmitting, and during the transmission time, the device continues to monitor the network from collisions, and if a collision is detected, the device involved stops to transmitting and wait for a random backup period before retrying. So despite its reduced relevance in modern network, CSMA-CD played a crucial role in the development of Ethernet technologies. It was foundation uh, protocol that enables that the growth of early local area network. Okay, so now let's discuss the collision detection in CSMA protocol. CSMA-CD, that means carrier sense multiple access with collision detection, is used in wired Ethernet networks. It allows devices to detect collisions and manage retransmitting. But CSMA-CA, it means carrier sense multiple access with collision avoidance, uh, used in wireless network, uh, and it's avoid collision by using RTC and CTC handshake mechanism. So CSMA-CA versus CSMA-CD protocols. So okay, now let's discuss the LLC and MMAC layer, which are the two sublayers of the data link layer. Uh, so the data link layer is responsible for the reliable transmission of data between devices on the same network. It is divided into two sublayers, which are logical link control and the media access control. So logical link control, that means the LLC layer handles the error checking and flow control, to ensuring the reliable data transmission. Uh, but media access control, that means MAC layer, manages access to the physical medium, addressing the frame synchronization. So importance of LLC and MAC layers are, those layers ensure that data is transmitted reliably and efficiently across the network. They play a crucial role in both wired and wireless communication systems. So in conclusion, LLC and MAC layer are essential components in the data link layer. Okay, so now let's discuss about Ethernet frame standards and IEEE 802.11. So Ethernet frames are used in wired communication such as Ethernet network. They have well-defined structure that includes the following fields. Uh, Following preamble and the destination and source addresses, type length fields, data payloads, and frame check sequences are the fields of affected with Ethernet frames. So IEEE 802.11 frames are used in wireless communication such as Wi-Fi network. They are most complex than Ethernet frames and include additional fields for control, management, and data. So Ethernet frames are used in networks such as office LANs and data centers, but IEEE 802.11 frames are used in wireless networks such as Wi-Fi in home, offices, and public spaces. Next, let's discuss about hidden station problem, a well-known issue in wireless network that can significantly degrade the network performance. So, what is the hidden station problem? That hidden station problem occurs when two or more stations are unable to detect each other's transmissions, leading to packet collisions. This happens due to the limited transmission range of the wireless device and obstacles like walls or other physical barriers. For example, consider three stations like A, B, C. So station A can communicate with station B, but station B can communicate with station C. But however, station A cannot detect station C. So if the station A and station C transmit data to station B simultaneously, their signal will collide at station B, resulting in data loss. So the hidden station problem can significantly degrade network performance by increasing packet collisions and retransmission and leading a high latency and reduced throughput. So addressing the hidden station problem is crucial for maintaining efficient and reliable wireless communication. By reducing collisions and retransmission, we can improve network performance and user experience. Okay, so now let's discuss about the export station problem. So what's this export station problem? The export station problem occurs when a station refrains from transmitting data because mistakenly assumes that the medium is busy. This happens when a station detects transmissions from another station that are not relevant to its own communication. For an example, consider four stations like A, B, C, D, and D. Station A is transmitting to signal uh, for station B, and station C is within range of station B but wants to transmit to station D. Station C detects station A transmission and assume the medium is busy, but even through its transmission to station D would not interference with station A communication. Uh, The exposed station problem leads to underutilization of the wireless medium as stations unnecessarily defer their transmission. So several approaches can mitigate the exposed station problem from directional antennas. These antennas limit interference to specific areas, allowing stations to transmit in non-overlapping regions without causing interference, and modified RTC, CTC mechanism, and advanced MAC protocols. Like research has proposed advanced medium access control protocol that enables smarter channel access decisions, reducing unnecessary referrals and improving network efficiency. So addressing the export station problem is crucial for maximizing the efficiency of wireless network. By reducing unnecessary referrals and enable concurrent transmission, we can improve network throughputs and user experience, especially in a dense and high traffic environments. Okay, now let's move on to the last capture, which is wireless standards and security. So, first of all, we'll discuss about wireless LAN standards, which are defined by IEEE 802.11 family of standards. These standards specify the protocol for implementing wireless local area network and have evolved significantly over the years to meet the growing demands of modern communication system. So IEEE 802.11 family of standards defines the physical and medium access control layers for wireless communication. These standards ensures interoperability and efficient communication across different devices and networks. So let's take a look at some of the key standards in IEEE 802.11 family. 802.11a, which operates in 5 gigahertz bands with maximum data rate of 54 megabits per second, and 802.11b operates in a 2.4 gigahertz band with a maximum data rate of 11 megabits per second, and 802.11g allows operating the 2.4 gigahertz band, but offers a maximum bit rate of 54 megabit per second. And 802.11n, it's introduced the MIMO technology, allowing operation in both 2.4 gigahertz and 5.5 gigahertz bands, with the data rate up to 600 megabit per second, and 802.11 AC operates in the 5 gigahertz band and supports data rates up to several gigabits per second, and 802.11 AX, it enhances the efficiency in high density environment, offering high data rates and improved performance. So evolution of IEEE 802.11 standards uh, has been driven by the need for higher data rates, improved reliability, and better support for uh, diverse applications. So wireless LAN standards have revolutionized how we connect and communicate, from basic internet access to high-speed streaming and IoT. These standards have enabled the growth of wireless network worldwide. So next, move on to the wireless LAN security. Actually, wireless network face significant challenges, including unauthorized access and denial of the services. That means DOS attacks uh, from the other security challenges. To combat these, we rely on advanced security protocol like Web3, which offers a strong encryption and protection against uh, for the attacks, and Web2, which uh, uses for AES encryption, and implementing best practice such as regularly updating firmware, disabling VPS, and using strong password is essential for maintaining network security. So our goal is to achieve secure and efficient wireless communication, ensuring that our network remain resilient against evolving threats. Okay, so that's the end of this presentation. Thank you for your attention.